So we're here today with the Saitek Pro Flight Cessna yoke. This is the younger sibling of the regular Saitek Pro Flight yoke, and if you've followed any of my previous videos, you know I don't hold that yoke in very high esteem. It's got lots of well documented problems with it, and it's really very unpleasant to fly. Now this one looks like it's the same unit with a different handle on. It's in exactly the same box. It comes with the same throttle quadrant that connects up to it in the same way. I don't have the quadrant connected here, but it's one of the same quads that I've got in my Twin Otter cockpit. So at first sight, you know, we're given to believe it's the same unit, but it's very hard to believe that that's the case, given that Cessna has allowed its likeness and its name to be plastered all over this. So that's one of the things we're going to be checking out when we put this yoke through its paces. To what extent is it similar to or different from its stablemate? Now the first thing that sets this yoke apart from its older sibling is that you're going to notice it has much more travel. In fact, the yoke handle will travel 90 degrees in each direction, 180 degrees lock to lock. As far as I know, that's unique in desktop yokes. And in fact, when you first plug this in, this is going to affect your first impressions, because it's going to feel like this yoke isn't very responsive. If you plug this in as a direct replacement for the other Saitek yoke, for example, it's going to feel like you have to do an awful lot with the handle to actually get, I'm talking about the aileron travel here, the elevator action is pretty much the same, but in terms of moving the ailerons, you're going to have to do much more in terms of moving the handle to get a response from the aircraft. And you might think at first, oh, this is rubbish, it's really sluggish, it's not going to be a very good yoke, but of course you have to go in and set things up appropriately. But what this does in principle, of course, is it gives you much more sensitive and precise control over the aileron axis. Now it's probably worth pointing out that you don't actually get any more precision in terms of the input to FSX. This is still a 10-bit controller, which means you get 1024 different positions of that yoke is all it can resolve. But you know, we're not going to make too big a deal of that. In principle, you should be able to get finer, more precise control, and of course more realistic control. If you look at the yoke in a Cessna 172 or Cessna Caravan, for example, those are default aircraft in FSX, you'll find that the yoke will actually do that. So you've got to go in and set that up in the FSX controls dialog or in FSU IPC if you use that, to make sure that that range of movement maps sensibly onto the range of movement of the virtual yoke. In fact, it's probably worth taking a bit of a side trip here to say something about that, because the way it works in FSX is a little bit obscure.
So what we've got here is a live view of the Saitek yoke and an equivalent view of the virtual cockpit using the default Cessna 172. If we look at the controls dialog, just note for now that we've got the aileron axis sensitivity set all the way to the right. That's maximum sensitivity. I'll say what that means in a second. What we're going to do is we're going to compare the movements of the real yoke and the virtual yoke. So if I wiggle the yoke, you'll see the yoke in the virtual cockpit moves. There is a bit of lag there. It should become clear what's happening in a second. If I rotate the physical yoke all the way to the left, you'll see that in the virtual cockpit we've got precisely the same orientation, and similarly to the right, same deal. What you might notice if you're watching carefully, if I try and move smoothly all the way to the left, you probably notice that the virtual cockpit, the motion looks different, and that's because FSX applies a non-linear transformation to the input. In fact, it applies an exponential transformation, and that means that towards the center, when I make small movements of the physical yoke, we get small and roughly proportional movements of the virtual cockpit yoke. So as we move away from the center, the movement of the virtual yoke for a given physical movement increases. So you can see out here near the limit, if I just move the physical yoke a very small amount, we get a large movement in the virtual cockpit. Just another way of illustrating that, what I'll do is I'll move the physical yoke so that the corner of the right hand handle is pretty much directly above the shaft. I'll have to move so I can see that. So that's about there, and you should see that on the virtual yoke that position is nowhere near what we have here. Then if I move it progressively further, the virtual yoke catches up. So as I say, the FSX is performing an exponential transformation on the displacement of the yoke, and that's something we can't get rid of unless we decide not to use the FSX controls mapping at all and use FSU IPC. We'll say more about that as we go. But what does that sensitivity slider do? Well, if I go back into the controls dialog and we move that, instead of having that on maximum, if I put that on minimum and we go back and we try moving the yoke, something's very different there. It seems very sluggish, and in fact what's happening is if we move the yoke abruptly, FSX takes time to catch up, and that's literally what it's doing. It's in a sense it's simulating a kind of a damping action, so we can't move the yoke too quickly. Now at its most intense, which is sensitivity on minimum, you can see it's ridiculously sluggish. What it means is if we're going to make large jittery movements of the controls, we're not going to lose control of the aircraft in the same way as we would if it was super responsive. So if we go back and we just set that to maybe a quarter of the way up, or let's say a third of the way up on the sensitivity slider, we can see again we get a lag, but it's somewhat more controllable. And really this is just another compromise that is built into FSX to deal with the massively diverse set of joystick controllers that people are probably going to be using with it. You might have wondered what this business with simple controls and advanced controls is. What you're going to find is if you set all your sensitivity sliders to be to the right and then you click out of that, if you go back in, you're going to find that FSX is flipped over to simple controls. Now you might be annoyed about that, but all that's actually doing is it's controlling all those sensitivity sliders on one slider. So if we go back, I think I'm right in saying this, if we put them all on minimum and flip out and then flip back in again, yeah, we're on simple controls again. So if we put that up to halfway, if we click onto advanced controls, we'll find all the sliders halfway. So that's the only difference between simple controls and advanced controls. It just links all the sliders together. So what I've done now is I've gone into the fsx.cfg and I've amended a parameter under the controls section called stick sensitivity mode. That's by default it's set to 1, I've set it to 0 and then restarted FSX. Now this doesn't remove the exponential scaling of the inputs that FSX applies, but what it does do is it changes the operation of the sensitivity slider. Coming back to the control setup dialog, sensitivity of the aileron axis is set on maximum here, and if we do what we did before, we watch how the physical yoke is shadowed in the virtual cockpit. We see exactly the same transformation, and we don't see any delay, so it's as if in our previous experiment we had the sensitivity slider set to maximum. The difference this time, if I go back and change that to, let's say, halfway up the sensitivity, we go back and watch how the virtual cockpit yoke shadows the physical yoke, we find something strange. We can't get complete movement of that virtual yoke. If I'm going lock to lock on the physical yoke, and I'm only getting a very small deviation on the virtual cockpit yoke. And essentially that's what that sensitivity slider now does. When you've got stick sensitivity mode set to 0, this slider simply clips, if you like, the effective range of movement that we can generate. And because that, although this is a linear slider, what we've got to imagine is this is a linear slider that's clipping the upper end of an exponential curve. So that means the effect of moving the slider in this upper range is going to be disproportionately large compared to the effects of moving it within this lower range. So if I put it on maximum and move it, let's say, quarter of the way down, we get quite a lot of that travel, probably about half the travel. It's going to about 45 degrees, I suppose, there. So that's the setting of the sensitivity slider and how its effect varies according to the setting of the stick sensitivity mode parameter in fsx.cfg. Now in practice, cut into the chase, if you're going to use the FSX controls mapping with this yoke, I recommend you have stick sensitivity mode set to 1 and you put sensitivity all the way to the right, and that will give you the closest to a one-to-one mapping, although it won't be one-to-one because you still have that exponential effect, which means that as you get further out from the center, effectively the sensitivity increases.
Something else about this yoke handle that differs from the basic Pro Flight yoke, which you may not notice until it's pointed out, is the way this handle is suspended differs significantly in this yoke. The shaft hits the yoke handle in this yoke about here, which means that essentially this handle is kind of like a pendulum projecting below the axis of rotation. With the Pro Flight basic yoke, it's kind of the other way around. It's the yoke handle almost sits above the shaft, and so it's I don't suppose the word pendulum is the right word, but it's like an inverted pendulum, so it sits above the shaft. Now in terms of how it feels, this probably has some effect on how the handle feels, but most importantly it has an effect on mounting the yoke. You can see the yoke here is mounted in kind of in my cockpit. It has to, the body of the yoke has to sit higher than if I had the regular Pro Flight yoke mounted here, so that the handle sits at the same height. And the limiting factor in my particular cockpit is if it's any lower than that, it starts to bump against my legs while I'm operating the handle. Particularly as this yoke has more travel, you know, it comes right down to there. So that's just something to bear in mind if you're planning to mount this in some sort of cockpit. So what else can we say about this yoke? Well, another thing you'll notice if you've got any experience with the other Saitek yoke, this one's heavier. It's actually quite hefty. It's obviously clamped to the desk here at the minute, but when you get it out of the box, it's quite hefty. And in particular, what you're going to find is if you just sit it on the table without clamping it, it kind of almost wants to tip forward, and that's a clue that this handle is heavier. In fact, this handle is much more solid than the handle on the Saitek Pro Flight yoke, and the reason for that's fairly straightforward. If you open it up, there's actually a metal, cast aluminium skeleton inside of this handle, whereas the Pro Flight yoke handle is simply a plastic shell, two halves of a plastic shell, and it's very insubstantial. So there's a weighty feel to this in terms of how it handles, whether that's going to make a substantial difference, it's kind of hard to say, but it just feels chunkier in operation. Beyond that, there are some great similarities with the Pro Flight basic yoke. It's at first operation, it's a very smooth action in both directions, but we do have that well-known and by design Saitek notch. You can hear that. That's the aileron action. If I move it through centre, you can hear a big bump. There's a very definite and quite precise notch at the centre, and same deal in the pitch axis. We'll probably say a bit more about that when we're on the go, but that's a feature that not everybody likes about this yoke, and it is something that gets in the way in certain circumstances while you're flying. The most damning feature of the other Pro Flight yoke, and it's yet to be seen to what extent this is a feature of this yoke, is that the elevator action, the pitch action, is not independent of the roll action, the aileron action, because of the way that aileron action is designed. Just in case you're not familiar with this, you may or may not be able to see this on the video. If you pull the handle all the way out and turn it over, you'll see a slot that goes through the handle, and it's that slot that engages with some sort of lever to operate the aileron mechanism. And historically the problem with that is, whilst you've got any aileron applied, that increases the friction on the pitch axis. So this is not the friction on the bearings that are supporting the axis itself, this is the friction between, I guess, the inside of that slot and some lever system that's engaging with it to operate the ailerons. Now, sitting here and tweaking this while we're not flying, that action isn't too obviously interfered with. I don't know whether I can imagine some interference. There is definitely some interference, and it's worse out towards the extremes, but it remains to be seen really whether that's going to be a problem while we're flying. Switch gear, I'm not too interested in talking about switch gear. Switches are switches. The main purpose of a yoke like this is to control the elevator and aileron axes. Everything else is peripheral really, but we've got switches galore. We've got an 8-way hat switch, we've got a 4-way switch here, we've got two 2-way switches here, we've got a push switch on the back of each handle, and there's a mode switch. You might see an LED on here. That's actually nice. If you're going to use this mode switch, that's nicer than the basic Pro Flight yoke, because there's a visual indication on the yoke. You get 1, 2 or 3 LEDs light up to say what the position of that yoke mode switch is. That switch, if you're not using the Saitek programming software, you may or may not be able to use that mode switch. What it does is it holds down button 28, 29 or 30, or 27, 28, 29, and you can use that in other software, notably FSU IPC or Linda, and you can use that for whatever you want, but generally it's used as a shift button, so it multiplies all the other buttons that you've got threefold. These buttons, incidentally, this 4-way one is very, very light touch. I'm not sure I like that. It's almost too light. You can just nudge it by mistake. And it has almost no resistance to click it really. But there you go, buttons and switches. So maybe the next thing to do is to take this thing up in the air and fly it around a bit, and we'll see how it feels. So the main thing we're looking for here is smooth and precise control over the ailerons and elevators, and as I mentioned earlier, we've got a lot of options in things we can do to finesse the way the yoke responds. I've set mine up with FSU IPC, and that's a good way to do it because it allows you to tinker with the response curve and in my experience that's particularly useful for playing with how this yoke responds close to the centre. So anyway, I've set mine up for what seems like a good response for this particular aircraft. What I'm finding is, although this yoke feels quite smooth when we're not flying, it doesn't feel quite as clean in the air, and I think that's because we're making lots of constant adjustments in both axes, perhaps without being fully aware of that. The other thing is this central notching, which is very noticeable and actually quite intrusive for subtle corrections. Now I knew that was going to happen because this is a well-known design feature of the Saitek yokes. That's this yoke and the basic Pro Flight. But what I'm finding is that instead of, particularly for small subtle adjustments such as holding back in turns, instead of smoothly pulling back on the yoke, gradually applying that back pressure, I'm kind of rocking the thing in and out of the notch, which can make the movements look quite jerky. I'm not really sure if that's going to be visible on the video, but it's a compromise that maybe once you get used to it, it's fine. The bottom line is, if you can make precise and subtle enough control movements, I guess the detail of that's not too important. Now in this aircraft, if we're trying to hold back in a turn, we're okay, because this is the Real Air Scout, and it needs quite a lot of up elevator to hold the attitude in the turn, so we do find ourselves well clear of that notch once we break out of it. Now this isn't the same for all aircraft, and it's one of the reasons you might want to play with the, well, in FSU IPC it's called the slope setting, but the envelope that describes how the mapping of the physical controls onto the virtual controls. And again, you can, if you use the Saitek SST software, I'm pretty sure you can tinker with that just as flexibly as you can with FSU IPC, perhaps even more flexibly. But you need to check that out for yourself. I've not run that software here. Just staying with the notching for a second, the aileron notch doesn't seem quite as intrusive, although it's still very noticeable. Maybe the difference is that we're using different sets of muscles. I guess for the ailerons, we're basically twisting the yoke from the wrist, which is a kind of a fine motor control, and certainly for operating the elevators we're using the, well, pretty much upper arm muscles. Now that seems like a significant difference. We don't have as fine control or such precise control over those bigger muscle groups. So now one important thing to say here is that we don't, in spite of that mechanical notch in each axis, we don't seem to have any dead spots in either of the two axes. Now by that I mean, in the basic Pro Flight yoke, most people report an interruption in the output from the potentiometer in the pitch axis and in the roll axis, as if there's actually a gap. So moving the yoke through quite a large deflection around the central notch produces no change at all in the output that's coming from the yoke. Now this is independent of any null zones that you've set up in either the FSX controls dialog or FSU IPC if you're using that. So even though you have no null zones set up in the basic Pro Flight yoke, you do get an interruption in the yoke around the centre of the roll axis and the pitch axis, and that by all accounts is by design, and that's very intrusive. Now coming back to the plot, we don't have that on this yoke, which is a good thing. Now I'm a little bit perplexed by this, because some people have reported, I think I'm right in saying this, that they do have that dead spot in the Saitek Cessna Pro Flight yoke, but all I can tell you is that in this yoke it's definitely absent. We get the full range of output right through the centre of each axis. Now this could mean there's some variation in the devices that are out on the market, either because there's a bug that means that flat spot is present in some yokes, or I suppose it's possible that Saitek has redesigned the yoke. Now one of the things I'm watching out for here very carefully is that interference between the aileron and elevator axes. Although it doesn't feel too noticeable while we're sitting on the ground, again under real conditions it's definitely there. Whenever we're trying to make elevator inputs with aileron applied, we do get some of that extra resistance. Although I have to say it doesn't feel anything like as bad on this yoke as it does on the basic Pro Flight yoke.
or at least on the one I have.
So one of the best ways of checking out this interference between the aileron and elevator mechanisms is to basically try and put it down in a strong crosswind. Then we're going to be operating the aileron mechanism assuming we're using a wing down approach, and we're going to be wanting to adjust the elevators subtly throughout the flare. So that should give us a real good idea of how well we can do with this yoke. So let's do that. We're at Israel's farm. In fact, we're at the chicken field next to Israel's farm. We're going to take off pretty much directly into wind, but it's a pretty strong wind, and we're going to turn the corner and set it straight down at Israel's farm with pretty much a 90-degree crosswind. So let's see how we get on. So we're taking off from the chicken farm. We're heading directly into wind here, and just for orientation, the strip we're going to land on, Israel's farm, is off to our left but converging with this one, if you like. So what that means is that headwind is actually going to be a crosswind from the right at probably about, I think it's about 70 degrees, and it's a 16 knot crosswind gusting to 19. So it's going to give us a good workout in putting it down, and we're going to use the wing down technique to do that, which should give us some quite significant manoeuvring through the flare, holding on a lot of aileron. And as you'll see, Israel's farm, if you're not familiar with it, is quite a narrow strip and not a very long strip either. So we've just done a bit of a 180 here, and we're going to try and stick it under about 1,000 feet. We're not going anywhere. The wind's hitting us from the left, so it's pushing us to the right. We're now turning pretty much into wind. What I'll do here is chop the power until we get established on the approach, and then we'll just see if we need any power to finesse that with. What I'm going to do here is I'm not going to use any elevator trim at all, and I'm not going to use any flaps, and that's really, and I'm going to try not to use any power. So that's intended to demonstrate solely the effects of using the yoke and the rudder pedals. I'm going to need the rudder pedals because we're going to be flying in a fairly enormous crab angle until right over the runway threshold. Then we're going to kick it straight, drop the wing. But until then, what you can see here is, hopefully you can understand what I'm doing here. I'm just trying to get the height right by crossing the controls and side slipping. That, in this aircraft, that gives a hugely effective way to manage your height even without using the flap. So here we are, we're still in the crab. We're going to kick it round any time now, just keeping the hand on the throttle in case we need some power. I've gone a bit long there, but we've got plenty of room. There's the nose coming round, wings going down, just trying to feed in some elevator there. There we go, we kept it on the strip. That's the stall warner. The stall warner in this aircraft is very noisy. Ideally we want to hear the stall warning chirp just before touchdown. So there we go. That's landing in a crosswind. So that's cross interference of the aileron and elevators. I think perversely in a situation like that crosswind landing, it's actually less noticeable. Maybe because we're making quite large exaggerated control inputs. So actually it's more obtrusive in turns where often we do need to, particularly in this aircraft, to hold some outside aileron to counter the overbanking tendency of the aircraft, and of course holding back at the same time to keep the nose up. But you know, I want to emphasize it's not as intrusive on this yoke as it is on the basic Pro Flight yoke, and although I haven't spent a lot of time with this yoke so far, it actually seems less of a problem than that notching tendency. which, don't forget, we can remove. You know, there's a lot of tutorials and chatter out there on the internet about how to remove those central notches on the pitch and the roll axes. So we could work on that if it was important enough. So this relative absence of the interference between the aileron and elevator axes was quite a surprise. So I was quite curious to open up the box and have a look at how the aileron action is implemented, basically to see if there were any differences between this yoke and the basic Pro Flight yoke. So that's what I've done. Now at first sight things do look significantly different inside the box. We've got this big white array of plastic parts at the front here, but essentially what we're looking at here is the gearing that allows that rotation of the yoke to be so much larger. The elevator action appears to be identical to the standard Pro Flight yoke, so I'm not going to look at that in any detail. But what's also interesting, and you can kind of see this on the close-up, the basic operation of the aileron axis is also, as far as I can tell, identical, in the sense that we have a slot running horizontally through the main shaft, inside of which sits some kind of pin. It looks like a steel pin, as best I can tell. And in fact, I'll show you that. Yeah, if you imagine this is the shaft, and I've got a pen here which I'm just going to use. I can't really illustrate this properly because there isn't a slot through it, but if you imagine that there's a slot through here, this pen represents the pin that sits in that slot, and so when the shaft rotates, that pin rotates with it and operates the ultimately operates the aileron potentiometer. But of course, because this is a slot, if the shaft moves in and out, that pin doesn't move with it. Now that mechanism that I've just described is absolutely identical in this yoke to the way it looks in the basic yoke. But there is one difference, and I think this is the explanation for why this yoke feels so different, and so much better in fact. There's actually two springs in this yoke, the Saitek Cessna yoke. They're difficult to see and the operation of them isn't really obvious from this picture, but there's two springs that, if I just show you on my little simulation here, so if you rotate the yoke in this direction, in the Cessna yoke you have one spring exerting a force that presses down on this side of the pin, and you have another spring that presses up on this side of the spring. So we have a balanced resistant force, if you like. That's not how it works in the other yoke. In the other yoke, you turn the yoke this way, there's only a spring on one side, so the spring presses down on this side. Now you get the same resistance to that twisting force, but there's some collateral effects that we don't really want. If you think about this, and if you have an engineering sort of mentality about you, pressing down on this side of the pin not only exerts a twisting force, it also tends to push this shaft downwards, and also I think away from the point at which the force is applied. And the net effect of that, as far as I can work out, is we get increased friction along the bottom of the shaft, or the bottom and perhaps the far side, because that's pushed down against the bearing. In the yoke that has the two springs, that push down force is balanced out by a net upward force on the shaft from the opposite spring. Now we do get some resistance from that sliding motion because that steel pin is actually sitting in a slot and it rubs against the inside of that slot. If you imagine it's in that slot and it's trying to twist itself out of the slot, so it's kind of rubbing up against the corners of that. And again, I've tried to show this a little bit more clearly on the diagram. Now you have to take the detail of that with a pinch of salt. I'm not an engineer, and I'm just putting this together from what I see. But you know, that explanation to me, it's certainly consistent with my experience of actually flying the yoke. So we do get some cross interference, but it seems to be much less than on the other yoke, and I think that's attributable to the essentially the pins scraping along the inside of that slot, and the removal of that asymmetric spring tension has really sorted this out. And it's also consistent, incidentally, with the people who say that, and I must say, you know, I was skeptical about this up to now. People do say with their basic Pro Flight yokes that lubricating the shaft does have some effect in mitigating the stickiness of the elevator action. I'm less skeptical about that now. You know, I can see how that would have a useful effect, if not completely remove the stickiness. But in this yoke, it seems they've made a design modification specifically targeted at sorting that problem out, and I think they've done a fairly good job. So that's pretty much that. This is the Saitek Pro Flight Cessna yoke, which is a very different beast to its older brother, the Saitek Pro Flight yoke. They've evidently done quite a bit of work to improve this yoke, taking out a few of the design flaws. They've taken out, let's just remind ourselves, the cross interference between the aileron and elevator controls. They've taken out the dead spot at the centre of the pitch axis and of the roll axis. They've made the whole thing beefier in the sense that it feels chunkier and more weighty, and of course that travel of that handle is now very much more authentic. Well, it is authentic, whereas in the other yoke, I haven't measured what the displacement of the other yoke is, but from my recollection it's about half. You know, you probably get 45 degrees in each direction, and that's made this into a much better yoke all round. And I have to say, against all the odds, I think this is actually quite a good piece of kit now. If you're in the market for a budget yoke, I mean, it's not the best yoke out there. Obviously it's still built down to a price. It will do what you want it to do. In this specification, it comes up to I mean, I often recommend to people that they don't bother with a yoke if they can't afford an expensive one, because the yoke is so much more complicated to build than a joystick. You're much better off with a cheap joystick. It will outperform many of the cheaper yokes. This one, I have to say, brings the Saitek yoke certainly up to par with a lot of cheap joysticks, and probably surpasses them. So at this end of the market, yeah, I would certainly recommend that this is the one to go for. You do pay a slight premium over the other Pro Flight yoke. It is a slight premium these days. I think the prices were a little bit more discrepant when this yoke was first released. But yeah, against all the odds, I'm saying something positive about Saitek.